In this video, I'm going to continue with different formulas to calculate B2. But before I proceed further, make sure that you are comfortable with these expressions that I have written here. This is what I covered in the last lecture, and these are really important. So have a look at this once again. So see what's happening here. Here you have one capital letter and one small letter. Here you have both the letters as small letters. Here you have both the letters as small letters. Basically, I have just changed the ordering of x and y here. Here, once again, you have one letter as small letter, which is your xi, and one letter as capital letter, which is your capital yi. So these four are equal, but note that these are not equal to summation of capital Xi multiplied by capital Yi. So when these four are equal, in these four, we have at least one small letter in the expression. Here we have small yi, here we have both xi and yi as small, here we have both xi and yi as small, here we have xi as small. So you should have at least one small letter for this to be true. In the last expression, we do not have any small letter. We have capital Xi and we have capital Yi, and these are not one and the same thing. Just to be more clear, let me show it to you as well. So I'm going to show that these last two expressions are not one and the same thing, and then you can show the same for the rest of the expressions. So the LHS that we have is summation small xi capital Yi, and I can write that this is equal to summation capital Xi minus x bar, because this is we have defined small xi, multiplied by capital Yi, and this is summation. If you multiply these two, then we get capital Xi multiplied by capital Yi minus x bar multiplied by capital Yi, and this is equal to summation capital Xi multiplied by capital Yi minus x bar summation capital Yi. Now note that summation capital Yi is not equal to 0. If you remember, in the demo sample, the Yi was taking 5 values, and the sum of those 5 values is summation capital Yi. The summation small yi is indeed equal to 0, but summation capital Yi is not equal to 0. So that means summation small xi capital Yi is not equal to summation capital Xi capital Yi. It is equal to summation capital Xi capital Yi minus this extra term that we have here. Okay, so now let's proceed with the formula to calculate B2. So I'm going to work with this formula, B2 equal to summation small xi small yi divided by summation small xi square. And now in this lecture, I'm going to derive a different formula to calculate B2, in which all the letters will be capital letters and there will be no small letter. So I'm working with this formula. This is the formula I'm starting with. So as per the notations that we have taken, I can write that B2 is equal to summation capital Xi minus x bar multiplied by capital Yi minus y bar, and this is divided by summation capital Xi minus x bar whole square. Now after this step in this formula, I'm only going to work with capital Xi and capital Yi, as we have substituted for the small xi and the small yi. So while completing the proof of this formula, even if I say just xi and just yi, it would imply that I'm talking about capital Xi and capital Yi. Okay, so now we can expand it. So we can write that this is equal to summation, and we can multiply these two brackets. So this will become capital Xi multiplied by capital Yi minus y bar multiplied by capital Xi minus x bar multiplied by capital Yi plus x bar y bar. So this is the numerator, and in the denominator we have summation. This we can write as a minus b whole square. So this will become capital Xi square plus x bar square minus twice capital Xi x bar. So this is what we get. Now let's evaluate it further. So we can distribute the summation sign in the numerator, and doing that we get that this is summation capital Xi capital Yi minus y bar summation capital Xi minus x bar summation capital Yi plus n x bar y bar. Now note that I have put n with x bar multiplied by y bar because x bar is a particular constant, right? So given a demo sample, you will have some particular value of x bar. Similarly, given a particular sample, you will have a particular value for y bar. And once you have a value for x bar and once you have a value for y bar, if you multiply those two values, you are going to get a constant only, right? So that's why I'm writing n here and not the summation sign. And then we have to divide this by summation capital Xi square, and this would become n x bar square because x bar square is a constant, minus 2x bar summation capital Xi. Okay, so this is the expression that we get. And now I'm going to apply a small trick to make it simpler to solve. So what I'm going to do is I'm going to divide this by n. So I'm dividing summation capital Xi by n and I'm multiplying summation capital Xi by n. So I can do this. I've just divided one expression by n and I've multiplied that expression by n. So it's one and the same thing. And I can also do the same here. So I'm dividing summation capital Yi by n and I'm multiplying this by n. So this does not change anything. And I'm doing the same thing here. I'm dividing summation capital Xi by n and I'm multiplying this by n. You will understand in a minute that why am I doing this. So see here that what have I got now? I can write this as x bar because this becomes summation capital Xi by n. So I can write this as x bar. And I can write this particular expression as y bar because this is summation capital Yi divided by n. So that means I can write that the numerator is summation capital Xi capital Yi minus y bar multiplied by x bar multiplied by n minus x bar y bar multiplied by n, and then we have plus n x bar y bar. So this is the expression that we have for numerator, and now as you can see, this and this gets cancelled, right? And now let's write the expression for the denominator. So in the denominator we get summation capital Xi square plus n x bar square minus 2 x bar. Now see, this becomes x bar and you already have a x bar here. So this is x bar multiplied by x bar. So this becomes x bar square multiplied by n. And that means now we get that the numerator is summation capital Xi capital Yi minus n x bar y bar divided by summation capital Xi square, and this is minus 2n x bar square plus n x bar square. That means this becomes minus n x bar square. And this is it. So this is one more formula to calculate B2, and in this formula all we have is capital letters. So we do not have any small letter in this formula. Now let's move to the last formula that we have to calculate B2, and thankfully that formula is an intuitive formula. So let's move to the last formula that we have. So once again I'm starting with this particular formula. So we know that B2 is summation small xi small yi divided by summation small xi square, and I can write that this is summation capital Xi minus x bar multiplied by capital Yi minus y bar divided by summation capital Xi minus x bar whole square. Now let's see how can I further write this formula in an intuitive manner. Note that we are working with a sample, and I believe that you know that if we have to find the covariance between x and y, and if we are dealing with the sample, then the formula to find covariance is summation xi minus x bar multiplied by yi minus y bar, and these are capital letters, divided by n minus 1. I hope you know this from your basic statistics that this is the formula to calculate the covariance between x and y when you are working with a sample. And let's also write the formula to calculate variance of x when you are working with a sample. So the variance of x is equal to summation capital Xi minus x bar whole square divided by n minus 1. So this is the sample variance of x and this is the sample covariance between x and y, and these are the formulas that we already know. Now have a look at the B2 formula that we have. If I now divide the numerator, okay, so the expression for numerator that we have, if I now divide this particular expression by n minus 1, And if I also divide the denominator by n minus 1, then I'm not changing the formula, right? I'm dividing the numerator by n minus 1, and at the same time, I'm dividing the denominator by n minus 1. So this does not change anything. Now, I can write the numerator as the covariance between x and y, because this is the formula that we have to calculate the covariance between x and y. And we have the same thing here in the numerator. That means instead of this numerator, I can write that this is equal to covariance between x and y. The COV dot is the short form that I'm using for covariance. And instead of denominator, I can write variance of x, because this is nothing but variance of x. So in the denominator, I can write variance of x. And this is the last formula that we have to calculate B2. So B2 is equal to covariance between x and y divided by variance of x. So this is all about different formulas that we have to calculate B2. And that's it for this lecture.